My name is Cathy Cassar. I am with Michael Baker. I have been modeling for over 20 years in one fashion or another with different software packages. Been doing 3D stuff for that whole time pretty much. I worked for Michigan Department of Transportation, rolled out 3D modeling within the state of Michigan, introducing OpenRoads technology to the state and getting the state to standardize on the 3D modeling with OpenRoads technology. Now I've moved back over to the consultant side, and I'm still happy to be sharing information and teaching how this stuff works. It is persnickety. That's probably a light way to put it. There's a lot of things that can trip you up and get you frustrated. So I'm going to talk a little bit about some of those things, as well as cover the basics of getting started with an intersection, a complex intersection. I'm going to have to jump through it fairly quickly because obviously a complex intersection takes more than an hour to design. So with that, I'm going to go ahead and jump in. I'm going to start with a PowerPoint, but I will show some live stuff as well. Which is, if you guys who know me know that I'm really not a fan of going live, so given that it may crash, we're going to see what happens. So I want to talk about intersection techniques specifically and how to deal with some of the complexities with using civil geometry. So for one, everybody should be fairly well aware, if you know anything about the OpenRoads stuff or even some of the other packages that do similar types of work. Smart models are going to save you time. You want to deal with ruled geometry, and those changes will then be dynamic. You want your whole model to kind of move together as you make your changes. You don't want to have to, forget. It's easy to forget where you have made connections to things if your information isn't intelligent and doesn't move and manipulate intelligently. So that smart geometry gives you that easier manipulation. You see your changes happen in real time as you make your adjustments and you see what you're doing to your model. It also helps, you can deal with lots of different users in different areas, referencing information together, pulling from each other to create a larger model of the whole. So it really allows you to break things up into segments and help the work flow a little bit better and still make sure all the pieces are talking together. Nothing's worse than seeing, two models coming together and they don't touch and they don't interact with each other, and one person makes a change and all of a sudden you get a large bump in your model, which is not something that you want.
Excuse me, Kathy.
Yeah.
I forgot to say, if anybody has questions, down at the bottom of your screen, there's a Q&A icon. Just hit the Q&A icon and key in your questions as you have them, and Kathy and I will both monitor it, and Cathy will answer it when she sees fit. Thanks.
Yeah, thanks, Chuck. Also, too, there's a time, civil cells are great. If anybody's used them, they have their purpose for sure. There's lots of things with a civil cell that can be done. Sometimes they just don't cut it. When you get into roundabouts, when you have islands within your intersection or the area that you're modeling, you've got more than two roadways coming together. If you need to be warping the pavement in any way that's not really your traditional crown scenario, these are cases where you could build a civil cell, but by the time you're done trying to make a civil cell, you've done all the work that you would need to do in order to actually have your model. So unless you've got, for some crazy reason, two of the exact same kind of ridiculous intersection in the same project, I don't know that making a civil cell actually is going to save you a whole lot of time. You might as well just go ahead and model it intelligently. So let's go ahead and take a look and see what we're talking about here. So this is an intersection in Southeast Michigan. This is one that I actually worked on quite a number of years ago, so I'm familiar with the intersection itself. This one has several islands that are in the intersection. It's three roads coming together. This roadway is in super elevation through this curve. You've got a lot of different things going on and trying to make it all work. These are pedestrian refuge islands, so there's sidewalk ramps that were taking place in each one. So there's the controls for the sidewalk that have to be taken into account. You can see the crosswalk here. So that was quite a challenge at the time when I did this original model, and I did it in OpenRoads SS2. This one I'm going to show you is with OpenRoads using GeoPack SS4 and some different ideas. It was very challenging in OpenRoads SS2 to kind of put this all together because it was not dynamic. So every time I had to make adjustments to one thing or another, I was basically going round robin around this thing, which is what happens when you don't have smart geometry. So you're trying to make sure all the pieces are working together, and I had to recreate a lot each time I made changes because they weren't dynamic and they didn't take those changes very well. So this particular intersection, there's alignments obviously for each one of these roadways. There are also corridor models. Each one has a corridor model. I kind of put together this one with its super elevation, and then each one of these roads. Normally when you have an intersection like this, you're going to know what your radius needs to be based off turning movements, truck turning movements, and things like that. So it's easy to determine where you're going to want to stop your mainline corridor. This section here is the part that will be included in the surface model itself. Obviously here you've got the roadway, we've got another section, this would probably be a civil cell, and then another model section would probably end up being over here. Given the simplicity of this side of the intersection, this one would probably just be a civil cell, would work just fine. But over here where I'm going to be talking, obviously civil cell, there's not anything in there that's going to be able to manipulate and according to that. That's just too much for it to do. So the place to start is to identify some baselines. So these baselines here are all smart geometry. And you'll notice I'm doing these off of the alignment. This is to eliminate the possibility of circular referencing that comes into play a lot of times. This particular edge, this is the scheme of my model. So this actually is built off of the corridor. Its parent is that corridor edge. And the reason is you want to make sure that because this is the scheme of two modeled surfaces, from the roadway to this complex intersection model, you want to make sure that this ties in exactly and that the seams are solid, so you don't have any type of a bump or gap or break between the two. So in this case, I'm not coming from the alignment for its horizontal position. I'm building it right off of the model itself. The only caveat to that is, should something happen to this corridor, this could cause my surface model to have a problem. And then you've got to do basically a reattach on the rules and try and see if you can get it to work. So that's the only precarious point with doing it this way. But as long as your horizontal geometry is tied to those mainline alignments, you shouldn't deal with a lot of circular referencing issues. So these are just single offset partials. Hopefully everybody's familiar with this tool, single offset partial, off that mainline alignment for the limits of where I know the radii are going to end up being. So we're going to get into the layout of the radii. So in this case, this is just a regular arc between, and you notice I'm not allowing this arc to clip anything. So my trim extend is currently at none. And the reason is I don't want to make intervals of my through baselines. If these become intervals, sometimes it's challenging to get intervals to accept or to send vertical information to another element. So I typically don't want my baselines at all to be intervals. I want them to be something else. And I noticed that this one is an interval in this file, that I changed it in the vertical file because it was causing problems. So you typically don't want anything here to be an interval. All right, so let's look at the islands a little closer. So this island, in this case, is coming from this complex curve here at a specific offset distance that was to be based off truck turning movements. This island then comes again off of the main line, not off of my edge. Again, I don't want any type of circular issues going on, so it's better to build off the main line if I know it. Same thing here. This radius offset to there, and then this one again off the main line. And then each one of these allows me to go ahead and create the radius. Each one of these are smart geometry, and they are tied to this. Now in these cases, I will clip the island edges because they're not my core baselines. These are elements that I will end up creating vertical information for. So that's generally how that layout would work. All of that, and that doesn't take necessarily too long. And you'll notice my edge lines do cross that main line edge here. I'm coming across it, and that's because I want to be able to get the vertical information precisely at that edge to make sure that all of these baselines actually will connect and I don't have any odd bumps or gaps in my terrain model when I get done. And one of the other things is, so the last thing is some control points, or some control lines in this case, that I find have been really helpful in the past. So in the case of these islands, knowing your perpendicular to the end point or to the key point of that radius becomes really important when you're trying to control any warping that you may have to do inside of the pavement. So these are just perpendicular from the main line. They come out and they hit that end of radius on each one. Actually, they're connected to the tangent, not the radius itself. In case I have to change or move the radius, then it will impact the tangent, and then these lines will adjust accordingly. So these are great. You notice I have them at all the radius points in order to be able to lock that in. If I need to do any type of pavement warping, that becomes critical. And then I also have my edge lines that identify the limits of my surface model. So I'll tie into my main corridor 3 here, corridor here, and then right along this edge will be how this will be eventually created. So that's the general start of the layout. And you'll notice, like I said, it's all civil geometry, it's all intelligent. And then once I get into the vertical aspects of this, then we'll be able to see how you can use these reference lines in order to manipulate the model itself, these edge lines and everything else within this model. So before I jump into vertical, does anybody have any questions about the layout or how I created it? You can wait a second or two before I jump models. Okay. Not seeing any, so we'll go ahead and move into the vertical. So from a vertical perspective, there's a few things to pay attention to. Specifically, I want to start with this edge. There's a couple of things with the way that the software works that can really trip you up. For instance, this edge, I did it a couple different ways, and I'll zoom in here on the line. First, I took the vertical tool profile slope from element, and I did the 2% slope on this from my mainline alignment because that's what the super elevation was. And I also did the vertical from, I used this as well, and with a 0 offset from the corridor element. So from this modeled edge, I also took a profile. Now, this roadway is in a vertical curve, which causes a number of issues that you should be aware of. These are some pitfalls you can run into. So you notice the difference here. This intersection point is this point right down here. This one up here, sorry. Mainline limit 1. Limit 1, yes. Or it's the south limit. So it is this one. And you notice this one here is a 2%, and I'll show it to you. I took from the alignment a solid 2%, which is what this roadway is supposed to be doing. And this is the active profile of that point. And this line that I created, I now have this issue. I have 3 different locations. Okay, I've got the south point, which is I know the 2% from here. That's that point right there. This is the modeled edge. This is me reading this blue line directly and putting it as a profile. And the third is me taking it and going profile slope from element at a 2% slope from this mainline edge. And you'll notice what we run into here is I have 3 different locations. That makes it really hard to make sure your models are going to tie down. That's one of those challenges that you have to pay attention to. just because, especially when you're dealing with vertical curves. If you just have a tangent, you probably won't see much of a problem. And we have that here on the northern edge, this limit line up here. Here is, I only have two solutions essentially. Here's the modeled edge and where it comes in. This is the main line at a set 2%, and this is the point that is a 2%. And the reason that these two match, because I did 2% here, and this, because this is in a tangent. Because the profile is in a tangent in this section, the 2% and 2% for the two different solutions gives me the same answer. Where you don't get that same answer is when you have any type of vertical curve, and then you're going to have to be very cognizant and do some math on your own to make sure you know what the answer should be. This is where the model can kind of trip you up, and you can end up with problems when you're trying to connect two models together. So it's just a little issue, especially in this SS4 version of the software, where chording comes into play. So what's happening essentially is each model has a chorded component to it. You have a template drop, so this was done with a specific template drop and a particular linear stroking, and then the profile curve stroking. And that will dictate the number of points along this line. When I did the offset line, it essentially it inherited the linear stroking. However, it starts at a different point. So 0, the origin of that stroking, becomes this point right here where it began, not necessarily the same stroking distance or location as this. So we end up with offset in the stroking, and that gets really complicated. But what it means is you end up with this. Okay, so you're hitting that curve at different points in the stroke, and you're getting a different solution because it's modeling across two known points and interpolating the data, so to speak. So it gets very difficult. So what you have to do is then I typically will trust my 2% from here because it's one spot. I don't have to worry about chording. I don't have to worry about anything. So I like these limit lines, and I'll put that exactly at 2%, and that will 99% of the time give me the correct solution when I bring these models together, that it actually looks the way it's expected to. Sometimes it ends up that won't work right, and you end up having to take that modeled edge. You're going to have to get into it once you start seeing and you build your boundaries and you start looking at all the information together, which I'll go over when we get into the surface part, where you can actually control and make sure you're actually snapping to the model scheme that you need with the boundary element that will actually allow you to control that model and make sure you're 100% tied in correctly. But I wanted you to understand that there are some caveats that you need to be aware of on how this stuff is going to give you solutions. So just because you gave it a rule and you gave it a suggestion that I want it to go this way or give it a definition doesn't mean that you actually got what you expected. So you have to be aware of these things as you do your modeling. So the other thing I want to just kind of talk about vertically is the two different approaches for these particular islands, and it's going to depend on what you're running into. So in this case, I actually put in set slopes for each one of these control lines here. So in this one, I wanted to be 1% here, and at this line, I wanted to be still draining toward the island, but less, as I'm trying to blend in to the pavement section over here. So to do that, I basically created these intersection points, so profile intersection point for this line to get the information, and that's what these 2 points are here and here. They're these two lines. And then as well as what is the point at the edge, which is the first line, and what is the point here, which is this point down here. So I wanted to understand what was happening for a vehicle that was traversing this fly around or auxiliary lane or whatever you want to call it. You can kind of see what this vehicle is going to be experiencing if I maintain set slopes across that in order to make sure that I, one, have drainage, and two, that I have ADA compliance or sidewalk ramp compliance where they were going to fall within here, which is at 1.3%. I know I've got a nice flat surface here that's going to work for those sidewalk ramps. So this is one school of thought. you can control these, you can move these up and down, you can kind of manipulate those, and it will manipulate the edge of this island and subsequently the radii that go around it in order to make this island work. That's one school of thought. And that works when you know you have to have very specific slopes that are across this, or maybe across this element right here. The other idea, which is something I do more when we get to Michigan lefts, is to let this one inherit its slope directly from what's happening from here to here. So these 2 points here are where it's intersecting the edge and the edge. Let me turn that corridor off. So I just want a straight line across just to kind of see. And that gives me a 1.7% slope. That should be fairly gentle from one perspective, but if you think about it, this road is in a 2% super this way. So that might not, in the end, be the best solution to be able to have this. You're going to end up with quite a jump between that pavement as the vehicle comes across. So it depends on, again, what you're trying to achieve and what you're doing here. So this gives you an idea of what's happening across here, but it might, in the end, not be the best scenario if you don't want your vehicle to have a kind of a bump from a 2% that's going this way to a 1.7 that's going that way. That's a 3.7%, you know, break, which would be quite jarring for a vehicle. So just to kind of understand, you know, some of those parameters and things you got to be mindful of. In that case, you might want to do more of the same scenario that we did over here on here to make sure that you're transitioning this pavement a little bit more gently. This one just would inherit its profile from either this edge or the main line, depending on what you're doing. And then in here, we get into something a little more complex. I normally put these points in ahead of time, so we'll talk about these islands when we look at the surface model. Does anybody have any questions on the general controls for vertical getting this to work? Not seeing any questions. Okay. Either everybody gets me or I'm way over your head. All right, so then I'll go into the surface model itself. So in a final surface model, in this case, we've manipulated these edges. And in here, this line, you'll notice, goes beyond the limits of what my model would be. However, its elevation information is only coming from the points where the vertical profile is. So this was the projected profile based off of this vertical alignment. These are what it ends up being when you create the profile to make sure you're tying into everything. So in this case, I'm tying into my edge. I'm tying into this control point as I'm warping the pavement here. I'm tying into this edge as I warp the pavement some more, and then making sure I'm touching back down here where my model needs to tie into the other model. And there'll be a small change in slope, but not bad. And this becomes my vertical profile. So in the case of these, to warp it, that I can tell here what's happening across here as I warp this pavement. This point here is intersection. So I can kind of see what's happening as I come through here to do this model for this island. Likewise here, I wanted to be able to see what I was doing and take a look at that. So that's fairly, I'm warping the pavement to flatten it out as I come to this large open space of pavement where the vehicles are typically not turning, but they are going to be turning, I should say they're turning onto the main line, but they won't be making this maneuver at all. So the vehicles are really just making the maneuver from southbound onto this leg here in the one-way direction. And then likewise, same thing on this side, a similar approach with the warping. This is at 1.45. 1.1. So you can kind of begin to see how you can manipulate this area of the pavement to make everything work. This is, like I said, always a good check to make sure my island is going to work on this side. And this is just a straight shot between these 2 points. So once you have all that, you can create an overall surface. That's a pretty easy scenario. Normally what I would do for that is just to select all of those elements, and typically not these, and you do the terrain model, terrain from elements. And these are all break lines when you do that. So when you hit that create terrain from elements, you want to make sure you're bringing them in as break lines. You might think about the boundary from that perspective. What I also have here is a boundary element. Right here. This boundary I got by doing this process essentially twice. So I'll go ahead and delete that. I'll turn the boundary off. So you select your elements. Let's get them all. Create terrain from elements. Boundary. And you'll get a big surface. And it's typically not what you end up wanting it to look like. I missed that one. So you have this. The only way to get that to clean up, you have to actually unlock it. If you deactivate that as a rule. And then you can use this Edit Terrain Model tool and clean up all the junk. What's nice about this tool is it will not delete across a feature that's actually there in your model. So you can come in here and you can delete all that and you can get a cleaned up terrain model. And I'm going to go ahead and delete it so I don't have to do the whole process. Here, once you have that model, you use this tool right here, create a terrain model boundary, and it will create for you that outside boundary of everything that you just did in your clipping. What's really nice about that is this is a 3D line string element. All right, so you can manipulate this because it's got all these handles. So in the case of that other corridor model, if I load up corridor 1, if I was trying to bring these together, not the curb, I didn't take the time to clean up all that curbing and everything, but if you were to take that off, and I was trying to bring these together, I could basically make sure that my clip boundary was connecting to my model, and if it isn't, I can physically move it, move those points, and connect them directly to the model, which is really, really handy to make sure that your seam is connected and coming together. You can just pick them up and move them, you know, any of these points. And you can put them on the edge. So if you find that your seam didn't quite work and your model has a gap or you have a slight differential between the two, that boundary becomes your best friend because you can move things around to make sure you're manipulating the model line itself to make sure that you're connected. It's really helpful to add that boundary. And then once you're done, you move it, you can put that boundary and add it as a feature, as a boundary feature. I think I deleted my surface, to that surface model. So I'll delete the feature, or I should say I'll delete the terrain model once I have created my boundary. So all I have is that. You turn that corridor off. And then it's just a redo of the process. I'll turn the boundary off. And then it's that same process again. Select that, create terrain from elements, add break lines, add my break lines, go into my boundary, I'll turn that on. Got my nice cleaned up boundary. I'll add that back to my surface now as a boundary. A couple ways to do it. And I have a completed terrain model. That's just the top, obviously. So from there, you get the option to add, you want to go down and add your other layers. And that's just done using your standard surface template. Surface templates work, they just take whatever's from the green dot, whatever down. Obviously, if this was the road section, you want to apply the same section to your intersection. And you get a surface model. Now, if this doesn't create the best contours, sometimes what you end up having to do is add some additional longitudinal features in here. You could add a line through the laneage to increase that. You can change the density of any one of these. So right now the stroking on this is set to 5. If that's too sharp, then you can change it to 1 for a radius. So these are all really dictated on those stroking tolerances that are provided for you in the workspace. Okay, so for some states, like you'll notice how corded this looks. This is what happens on a 5-foot radius. But if you were to take a little time when you're trying to put something together on a tight radius like this, if you make it 1, you'll notice it gets rounder in appearance. There's a very slight change. So it really depends on what you need from that model, but you can see how that looks. It's very broken in its appearance. If that's creating problems, it doesn't look good, you can make those changes to that linear stroking. Some states are 25 feet, some are 10, some are 5. Most of them I'm noticing now are 25 feet in this linear stroking. So can you imagine that on a 25 foot, you're not going to get much at all in any type of definition. It starts to really get odd when you dig into those larger strokings. This curved stroking has some impact on it as well, but it really helps on a tight radius. You can see the difference in how many more you have to round that out and give it a better appearance. This can be really helpful if you're using your 3D model data as your plan view. You want to make sure that those have the best curve appearance, if that's your case. So if not, then maybe it doesn't matter as much, but if you want a nice smooth surface and you want your contours to come out really good, if contours are your output, then those are things to take into account. If your feature length itself is shorter than the stroking distance, that can cause you to have not enough points in there as well, and you'll have some inconsistencies in that overall surface model if you don't take that into account. So there's just some fine-tuning to consider. And some contours. So there's different, the contours themselves, what you see in them varies greatly as well. These are controlled here. If you want to see your calculated features of your contours, you can get into them if you want to increase that spacing. Maybe you want 1 and 2, and you can see contours a little more detailed. This particular section is a little bit more flat in nature, so it's kind of complicated to model from that perspective. The boundary element, no, it is not exactly dynamic. So once you create it the first time and you have that boundary, it's a static item. It's not linked to the model. It's part of it. Otherwise, you end up with a circular referencing if otherwise. So the boundary is something that you have to kind of continually manipulate. Unfortunately, that can get a little bit frustrating when you want to work with it. And a lot of times too, if you manipulate this boundary, sometimes what happens if you get a real complex model like this is it starts to be lost by the model itself. So you'll notice your model won't update to that exterior boundary. So you just have to select it, remove it from the surface, and then add it back in. So it's a little bit of a convoluted step with it, but it does, when it's working really well. Second you move the boundary, the model moves with it. Occasionally you'll notice that you're moving the boundary and the model isn't moving, and that's the two have gotten somewhat disconnected in the program. So you'll have to just select your boundary, remove it from the terrain model, and then just put it back, and it'll automatically then hook back up again. But unfortunately, the boundary line itself is not dynamic. So if you're making large-scale changes to vertical alignments for the radii or the islands or any of the elements, sometimes it's quicker to just do your editing of your terrain again, and then go in and make a new boundary and start over. But that's the only downside to the boundary, is that it is not fully live and dynamic with your model. So from there you can add, once you have your pavement depth, you can add a bunch of bells and whistles, which I didn't do for this particular intersection. It takes a little time, but from here you can easily add linear templates or corridor models all the way around in order to get a more refined looking model and get your islands constructed. I never do the sidewalk ramps as part of my model. And I'm going to go ahead and show you a completed model from a different project that I just finished up earlier this year that actually has with it all the bells and whistles and everything done. So this particular intersection was also fairly complex. It had this island. It had super elevation coming through here. It had median islands in the various roadways. These were the final contours that were developed. It also had the pavement working here in this section in order to make all this work. It has the different pavement sections and also those boundary elements. So to show you the boundary, let's get into this. All right, so here are the two different boundaries. I made a boundary because we had a subgrade surface here and a top surface. So these boundaries were created because I had a bunch of different things that I was also connecting to. You'll see here I've got different surface models. These are from different models as well as another one on this side. So these boundary elements were used to make sure that I was interconnecting with all of those different models. And I'll show you these grading models. Here, all of these had to be connected, so those existed in different locations. So that boundary became a real key to making sure that I was absolutely 100% connected to each one of these edges and had no overlap in my models for my quantities, for my contour, overall contour file, and everything else that was going on with this. So that's a generally, this one was completed. This actually I think has now been released for construction. It was a design build, and I believe it should be getting underway here pretty soon. So in this case, there was some complexities for the subgrade. I had sidewalk conditions and things like that. So these boundaries become really helpful to make sure, because I was tying into an overall mainline corridor. I did the whole intersection here as one big model, and then connected to different parts of the main line. Just kind of chopped this section out and did it through the same kind of tools and techniques. Anybody got any questions? Other questions about the general surface? Oh, okay. So I thought this might be helpful to kind of summarize some of these tips. First off, when you're doing your baselines for your edges, you want to make sure that you are offsetting, again, from something known. Typically an alignment is the best one to use. You want to make sure that you're using that in order to make sure that you don't end up with a lot of circular referencing. You want to make sure that you're ruling your elements. Dumb microstation graphics can be used for a model, but they can also bite you in the butt. They do not update. They're not dynamic. Sometimes they don't respond well to changes. If you're trying to delete them out of surfaces, they can get stuck in the surface, and trying to find them to get rid of them can be challenging. A lot of times you end up having to delete the whole surface and then recreate it in order to remove those dumb references. So you want to make sure you're using your rules and that you verify that the intended rules actually got applied correctly. Especially again with those vertical offsets, slope from elements is not always correct, especially even if you're taking it 0 offset. If there's vertical curves involved and you're clipping a vertical curve somewhere inside of that curve, not on a tangent, you're going to find more problems than you would in the tangent section. So you want to make sure you're verifying your vertical offsets. These be very challenging, especially in roundabouts, when they come in wrong. And then your terrain model, you want to make sure that you're avoiding overly large models. If you get models and they're over probably about 20 gigs in size, or you're starting to push boundaries, and you're probably going to have problems. So a roundabout can be a fairly large model. Some of these complex intersections can end up being quite complex. File sizes are going to be important. And things like that. So I see a question about why would I manipulate the boundary? Isn't that considered a project limit? I'm not manipulating the boundary for the tie-down location at the ground from a slope stake line perspective. I'm manipulating the boundary when it's connecting two models together. So if I have a seam between an intersection and a main line, that boundary line that I'm creating, I want to make sure that that is 100% tied to the model that I'm connecting to. So it's always, I'm always manipulating, what I'm manipulating is the connection point, the seam between two models, not the slope stake line project limit tie down line. So hopefully that clears up the question. Okay. And then again, I can't stress this point enough. You really want to verify your slope from elements. Entire curves in an offset condition. Small stroking tolerance can certainly help. You want to simplify your features. You notice I didn't complex any of my horizontals going around curved lines and things like that. There are times when that might seem like a good idea. It can hurt you in the long run. If you're trying to do a slope that goes completely around and you've got a curve and two tangents, sometimes you have to complex across, but then you're going to want to build, either something on top of it or just really watch it, because if you have to break that element apart, it can really destroy your overall surface in the long run. So there's some things to keep in mind. I wanted to make sure I kind of touched on those. I think we have a few minutes left. So does anybody have any questions? Anybody want to see anything in particular that I didn't show or you felt I covered too quickly? Be happy to take any other questions you might have.
Looks like you did so good, Cathy, that nobody has any questions.
Either that or I lost everybody.
That too.
Do you have any questions? You always seem to have some.
Yeah, it was great when you worked at MDOT, but now that you're a competitor, I can't. So is your workflow now for these intersections, like the one we got on the screen now, that's all hand modeled?
Yes. Yep. Okay. I do use the linear templates and corridors to do all of the outside of the pavement.
Okay.
So connecting the sidewalks, bringing the sidewalks around, manipulating all that. These islands are all done with I typically use corridors as opposed to linear templates. I have better luck with them. They have better controls and more options. So I'll typically create a corridor that kind of runs for that island. Any islands like that are corridor models. These edges where all these sidewalks and different dimensions for sidewalks and things, those are all done with corridors and templates. But inside the pavement is pretty much, that's done by hand manipulating. You'll see some of my lines in here to add some definition. Or in this case, because I was doing a lot of warping, here's my lines in here to determine that warping for this edge. These are all the controls that determine what's going on here to make sure that it actually blends correctly, going around this auxiliary lane.
Can you just show real quick how you brought in those lines to control your edge, those vertical lines like at station 33, I think it is?
Yeah, right in here?
Yeah.
Okay. So, is it done in this file? I'm trying to turn off the 3D so I don't keep getting tied up in that.
And you also have another question.
Yeah, actually, I think it's a similar one. Can you summarize how you added the pavement warping on the hand-modeled intersection? So in this case, these were dumb lines, and I wanted to make sure that I was warping this pavement coming through. So I started here knowing that this was in a super elevation, and I wanted to tie into that. So this point here is the point over on this edge, which is my edge coming through for that supered section. So I knew I was at 1.48%. This is, I think, a different line. This is for checking these sidewalk ramp conditions. This is kind of what's happening here, and this is just for me to see what's happening to the pavement. I just kind of see those intersections.
Those are just microstation lines then?
These are microstation lines, yeah. Like I said, I use these sometimes, but I typically will not add them to the model. They're used as my controls when I use them, but I would recommend that you actually use smart lines as opposed to microstation lines. I ran into some hiccups. If I was adding these to surfaces, actually adding it to the surface, right, I would make smart lines. But because I was just kind of using them for checks and controls, I did not in this case. But I did run into some trouble down the line. So now I've gotten to as I get further along now, if I did these earlier this year or late last year, I've gotten to the point now where I like to use the smart lines for everything. I've gotten away from using dumb microstation lines for anything when I'm modeling. Oh, okay.
So then you just drew the vertical line in there, but you didn't set it active, right? That's just so you can see what the percent slope is.
No, it is active. It is active, so I could then see what was happening here across this island. Okay, so this is smart geometry, and I wanted to see what was happening. So there's a point there. It's really tiny. So I'm actually then just snapping across these lines, and I could see what I had as a slope, and that became the slope for that island.
Okay.
Here. Okay, so I used them to control this island, but these lines themselves are not in my terrain model.
Okay.
You know, you don't see them in here. They're just control lines. So then I was 1.65, and then I was trying to get myself back down, and I had to use essentially the rate of super, and I calculated what I needed to be, because I had to be back over here, sloping back in this direction, so that the vehicles, as they came through this auxiliary lane, were sloping northward, I guess, if you were, toward that outside edge, right? You want the car to come around, and it almost feels like a ramp, right, going around that edge. So I had to make sure that I was starting off from that same slope toward the outside, not toward the inside island, right? So this was 1.5% here, and then I used the super calcs to figure out what the distance was that I needed to be and what I could be as far as a slope, and when I reached here from a warping perspective. So the cars that are going around get the bonus of kind of a super elevated slope scenario. Here's this one. It's coming down. I had to be exactly, this was quite challenging. I had 2% from this edge downward to connect to this pavement down here. So it was I scratched my head at this one for a while, but as far as a warping perspective, I used, again, some common sense, some practical experience from being in the field building, as well as just then the actual calculations, super elevation, transitions, and things of that nature to determine what was going to be acceptable from a transition standpoint. And then so this pavement edge warps considerably.
Okay.
But it works. I mean, if you look at the contours, this would be a pretty good ride. Going around here, and then a pretty smooth transition into the super elevated section.
All right.
Hopefully that answers the question that I see. We got a few minutes left. I don't know if anybody has any other questions.
It doesn't look like it.
Doesn't look like it. Yeah. So anyway, so this is like, challenging because you've got the catch basin locations you're tying into, the low points you got to get, sidewalk ramps, all those things come in. This one was extremely complex. You notice I had all these sidewalk ramps that I had to make sure I was no more than 2% slope across any of them, and across the pavement at the location too. So it was pretty interesting project to work on, this particular portion of it. Interesting and being nice.
I just got one other question. This is kind of a silly question, but for these islands in the middle of the road, I know on your templates we have the curbs and slopes and everything else. That's fine, but do we really need to add that? It's simple, just adding linear template, but does MDOT really require us to put curbs on these islands in the middle, or can we just go with the pavement surface level?
I think it depends. I don't know. It depends on what it's used for, right? Obviously, they're not going to do the grading
Right.
with that. If you pavement all the way across, that might be, misconstrued and not necessarily representative of what you're doing there. From a subgrade, if you need the subgrade for any reason, then that might be a reason that you might want to see, that information so you know where the bottom of curb is. And one thing you could do is, instead of modeling across this, like I did here with the curb lines and everything, is you could make a shape out of this and add it as a void. From a terrain model perspective, you could just go ahead and add it as a void to your model, and you cut it out that way.
Yep.
So that was done on this model over here, because I had this area underneath this pet bridge. So I just used this shape and I cut out everything for that particular model, so that there was not a right there. See it? This was actually, part of the structure. The wing wall, the walls and stuff were going to be here.
Right.
And part of the underneath. So any flat shape. So this shape here has no elevation to it whatsoever. This is just in 2D view. It's flat, no elevation at all, and you can still use that as a clipping boundary, essentially, to create a void. So I just used a drape void in this case, which is drape void. So it actually pulls its elevation from the terrain model that it's going to be connecting with. So I'm not altering the elevations here whatsoever in that cutout area. I'm just using that shape to determine where I want to gap the surface model.
Okay.
So that's what you could technically do that for your islands as well. If you don't want to show, if you don't need the contours, you don't want the curved lines, you just want to gap that out completely. That's a way to go about it, is to have just a closed element shape and be able to use that to clip everything out.
And it's probably not just me, but it just seems like we really still don't know what the contractor uses these models for. I mean, they don't need that curb there to build this intersection, but we put it in anyhow.
We put it, well, there's always there's two things, you know. One, from an engineer's perspective, I like to see as much complete as possible because I like it to look good. I like to see it. You know, I have a young guy that works with me that likes to see it with all of the bells and whistles on. You know, he likes to see everything and, you know, see all the curbs and everything. And, you know, they like, you know, it looks good. You know, if you take it and then you put it in a, you know, you can start to see what your pavement looks like and all that kind of stuff. There's a lot of folks that like to see it look like that just so they can see what they've got.
Right.
I always work in string perspective. So in this case, you know, I don't have any green in here. I didn't model anything back here. The surface, when it connected the backs of this information, closed the gap, but I didn't actually model it.
Right.
The only time I would need this, you know, because one, there's sidewalk ramps in here. I didn't model the sidewalk ramps. No intention of modeling the sidewalk ramps. So the curb drops aren't here.
Right.
You know, so, and I didn't model all of this complexities with, you know, what's going on in here with the, you know, I didn't get any of that. They did that by hand, essentially, you know, using the edge of pavement to determine what the slopes would be. And I even think that's a bit much because, quite honestly, you know, as long as you know that this will solve correctly and meet requirements, I don't know, you know, we're still doing detailed grades for stuff like that, which I think is a bit much because all it takes is this edge, and this edge to be within the buildable tolerance, and we're off. So.
Right. All right. Well, I don't see any more questions, Kathy.
Yeah, I don't know. It's always one of those things that's out for debate. I don't know that the contractor would use it. If they were doing a string line for this island, they might want the curb lines just so they could have it, but
right.
It is a direct relationship from the edge of pavement. It's not like it's hard to get. They didn't get it.
Okay. Well, if there's nothing else, no other questions, thank you very much, Kathy. That was great. We appreciate your time together. And the video will be available on the website and the YouTube site probably by the end of today.
Will that be videos, Chuck?
Yep. There's the one for our first webinar, and I'll add the other one there. So like I said, if you have any questions or concerns or about the user group, you can go to glbug.com and go to the contact form. Send us any questions. If you go to the homepage, we're still looking for some survey responses to our upcoming 2-day conference, summer of 2020. So if you just fill out that survey that's going to pop up in a second, you got to give it a second. We appreciate it. We've got about half of the respondents responded. Right now we have 194 members from 12 different states and Canada involved in the user group. So things are picking up pretty well. So we appreciate everybody's commitment to this and participation. And I think with that, Kathy, I think we're all set. Thanks again.
All right. Thank you. I hope it was informative.
Very much. So with that, we'll end the meeting, and any questions, just contact us. And again, if you have people sitting around one computer, please send me the participant's name so you can get PDH credit. Just send the email to ckrasic@glbug.com and send the chat window. Also, I think most of you know, to get your PDH credit, you have to have a Bentley login, which I'm sure everybody does because an annoying login comes in every time you open up your computer. So, and then when you do, you go to learn.bentley.com, and down the lower left is the certificates section. Just click on that and you'll find your certificate there. But it'll only be there if you registered with your the email address you registered for. So again, if you're sitting around a computer with a bunch of people on one computer, just send me the participants' emails who need the PDH, and I'll get that to Bentley. So with that, thanks again, Cathy, and we'll see you maybe next month. I'll send the email out.
All right, thank you.
All right, take care.